5, 4, 3, 2, 1. Mark. Hi, I'm Commander Chris Hadfield, astronaut, spaceship commander, spacewalker, part-time musician. I'm here today to hopefully debunk some common space myths. Here's this common perception that you will immediately fry to a crisp by the unfiltered, unadulterated solar radiation if you get sucked out of the airlock. In truth, it's way worse than that. In the shade in space, it's like minus 250 degrees. But the part of you that's in the sun, it's plus 250 degrees at least. So it's going to start boiling and burning. So it's like lying on a red hot stove with a piece of dry ice on your back. And your lungs are going to be sucked flat instantaneously. But even worse than that is your blood is going to boil, like opening a can of pop where suddenly all the little bubbles come out because there's no air pressure around you. So simultaneously, you are going to freeze, boil, burn, get the bends, and no longer be able to breathe. Not a good way to go. I've done 2 spacewalks, and I was very thankful to have a spacesuit around my body so that none of those things happen to me. Sometimes you hear that you have to work out constantly or you will pass out and possibly die in space. Not true. Living on a spaceship is the most lazy existence you can imagine. You're weightless. You do not have to lift a finger. You don't have to hold your head up. Your heart doesn't have to lift your blood against gravity. You can be the laziest person in the universe in space. But eventually you need to come back to Earth. And if you don't exercise for your whole 6 months in space, you'll sort of turn into a jellyfish. So we do exercise 2 hours a day on a spaceship. We have a resistive machine, we have a unicycle, and we have a treadmill where elastics hold us down just to keep our bodies strong enough and our bones dense enough so when we get home, we don't just fall over like a puddle. But you don't need to work out all the time. You've probably heard that space has a smell, maybe like burnt steak or some type of barbecue. That's true. When you come in from a spacewalk, you're surrounded by the emptiness of space. It's sort of like the opposite of air. There's nothing there at all. When you quickly repressurize the hatch and you open up the hatch and you smell, what is that lingering smell from a place that used to be exposed to space? The smell in there is a little bit like that trace of a smell of gunpowder or burnt steak, or to me it's sort of like brimstone, like a witch has just been there. It's a cool, lingering trace of a smell. I think what it really is the emptiness of space, the vacuum of space, is actually pulling trace chemicals out of the metal of the walls of the ship. Little bits of stuff you never smell because normally there's air pressure holding them into the metal. They're slowly off-gassing those tiny little trace gases and trace particles that otherwise they never get into your nose. And those are released. It's sort of that metallic gunpowder-fired smell. That's where the smell is coming from. Maybe it's not even coming from space. It's just sort of coming from space's effect on our ship. Yeah, in truth, it smells a little bit like a burnt steak. So there's a lot of word out there that if you go incredibly fast, like the speed of light, if you could travel at the speed of light, that you won't age. And despite thousands of years going by, you'll stay the same, but everybody that you know will die. That's not really true. Einstein called it relativity because what he meant was your aging will be different relative to people's aging on Earth. You'll still age. Time will still pass for you, but people on Earth will age at a different rate. So that if you came back after going incredibly fast, you would have gotten older by the amount of time that it took for you to travel, but people on Earth would have aged much, much faster. They would have had a longer period of time because if you get going fast enough, your speed is sort of proportional to the time passing. So you'll still age, but you just age at a different rate than people back on Earth. Einstein did this cool thought experiment. Imagine if you were looking at a clock. The light from the clock is coming and hitting your eyeballs and telling you it's 12 o'clock. Well, imagine if you could move away from that clock at the speed of light. It would only say 12 o'clock because that light and you would be moving away from the clock at the same speed. So for you, it would look like it was always 12 o'clock forever. You'd still be getting older, but that clock would always look like it was the same time. The people on Earth were continuing to live. They're not aware of you going the speed of light. So you can see that the time for you, because of your speed, is relatively different than the time for the people on Earth. It's a really unusual thing to try and grasp in your head. What happens when something blows up in space? If something explodes in space, will it make a sound? And could a human hear it? It's a pretty easy question to answer. The sun is just an explosion. The sun is the biggest explosion any of us can imagine. It's a huge, continuous thermonuclear explosion. It's every atom bomb we've ever built, way more than that, continuously exploding. It would be the loudest thing imaginable. It's constantly happening, but we don't hear a whisper of it. And that's because there's nothing to carry the sound from the sun to us. Even though it's incredibly violent, there's nowhere for the pressure of all of that sound, all of that noise, to be carried across the emptiness of space to shake my eardrum in here and let me hear the sound of the sun. It's a good thing. It'd be deafening. So if something explodes in space, it makes sound, but there's no way for that sound to be carried across space so that I could hear it. There is this idea out there that maybe the only way that we could really create gravity is to spin the spaceship so that everybody is stuck to the sides like one of those rides at the fair where you're pinned against the wall. And for now, that's actually true. We don't know how to control gravity. We have no way to control gravity. We can sort of pretend there's gravity by spinning a ship and everything stick to the sides like a ball on the end of a string. Maybe someday we'll figure out how to control gravity. But for now, we have to spin the whole ship. Only in the middle would they be weightless. I've seen that people think that NASA is working on warp speed so that we can travel at the speed of light to interstellar planets. Warp speed is an invention of science fiction. If we knew how to work on warp speed, we would. We don't know how to go anywhere near the speed of light. It takes an unlimited amount of energy. The faster you go, the more energy it takes. E equals mc squared. It goes up with the square of the speed, in fact. So how can you generate that much electricity? And what does it do to your mass? We don't know. We think maybe it's possible that you could go faster than the speed of light, but we sure don't understand how right now. So we're not really working on it. So it's not really true. We're hoping for it. In so many movies, you see that the only way that they survive interstellar travel from one star to another is to freeze yourself into cryosleep. We don't know how to do that. Right now, when you freeze water, which is what we're mostly made of, our blood and everything, it goes into crystals. It turns into ice crystals. And if you allow the beautiful, delicate nature of your human body to expand into ice crystals, it'll destroy the structure of you. It'll kill you. Frostbite destroys it so that you get gangrene in your hand. You'd end up with entirely destroyed bodies. So right now, we do not know how to successfully freeze a human body so that it is not going to be permanently destroyed. Maybe we'll figure it out someday. But all of those movies that rely on freezing the crew, we don't know how to do that. It's not real. You see on the internet all the time, someone has built a balloon and they've launched some little figurine with a camera attached to it where they take a picture way up high in the atmosphere. You can see the curvature of the Earth. It's pretty cool. But there's some people thinking you could fly yourself all the way up to the stratosphere with some sort of high-altitude balloon. You can, actually, but it's really complicated. Felix Baumgartner, when he did his leap out of a balloon and actually go through the speed of sound, falling down towards the Earth and landing with a parachute, he was way up into the stratosphere. The stratosphere starts at about 6 or 7 miles up. It's not all that high, but it goes on for a long way. There's not enough air to breathe. You kind of need to have an airliner with the pressure inside to keep your body healthy if you're that high. But if you take the right equipment with you, yes, we can use a balloon to lift us high enough to get all the way up into the stratosphere. So if you have the right equipment, it's true. You've probably read somewhere on the internet that if you go to the space station, your body will get taller, sort of expand, and it'll be painful, and you're going to be taller forever, an irreversible experience. And it's not really true. As I'm standing here talking right now, gravity is pushing me down towards the floor. Every single bone in my body and the little bit of gristle that's in between the bones, like each of the vertebrae of my back, every one has a little disc in between each of the bones, and even my hip bones and my knee bones. There's a little bit of a gap. Well, if there's no gravity pushing me down, then those gaps can all get a tiny bit bigger. If you stay in weightlessness for a few weeks, in fact, your body just sort of stretches because the gap between each of the bones gets a little bigger. And in my case, I got about that much taller. But you aren't really taller, you're just sort of temporarily longer. But it's not permanent. As soon as you get home and gravity starts doing its work on you and grinding you down, everything squishes back down to its launch. So you may be for a little while a little bit taller in space, and it may hurt your back a little because everything's sort of getting pulled tight. Some people have back pain in space as a result, but it's not really growing. It's just sort of stretching to your natural maximum that you're going to get squished back again as soon as you get home. If you do get maybe that much longer after you've been in space for a few weeks, think what your pants would be like. They're gonna be high above your ankle. And if you put on a spacesuit, who custom fit the spacesuit to the size of your body? But we know it's going to happen, so we actually plan in advance. We fit our spacesuits knowing that the astronauts are going to be a little bit taller when they're in space, or at least their bodies are going to be a little bit stretched. And even the seat that protects us when we come back to Earth, the crash seat, so that when we hit the ground it protects us properly, we allow for the fact that our backbones are going to be slightly longer when we're up there. But your clothes, you don't really know how they fit because you're floating around weightless. Your shirt is always floating around your body. So you never really have a sense up there how well your clothes fit, just because there's no gravity to pull them down and look and see how well they're fitting on your body. It's more like they're just floating next to you. I've read somewhere that on board the International Space Station, bacteria multiplies 10 times faster in space. So if you get sick, your body's going to be like torn apart by this ravenous strain of mutant salmonella. Nah. It is a different place than Earth, the space station. We run around with little swabs all the time to measure what microbes and what viruses and what little tiny bits of life might be growing on the spaceship. We also go around with little cleaners and wet wipes and wipe down the whole space station all the time, like in a hospital, to try and keep the whole thing clean and hygienic. And we are finding that some of those primitive forms of life do mutate slightly differently in the high radiation, weightless environment of the spaceship. But no one has died yet because of the mutant salmonella. I'm Chris Hadfield. Hopefully, this has helped answer some of those common space myths.